Hello students, my name is Arshan and today we are gonna do the fourth chapter Heat of your 7th class science textbook of NCERT. In the previous chapters, we have studied about animal fibers, plant fibers, fibers like wool which is an animal fiber, fibers like cotton which is a plant fiber. You may have noticed that in summer conditions, in summer weather, we prefer to wear cotton clothes, light colored ones, and in winter conditions, in winter weather, we prefer to wear woolen clothes, dark colored clothes. You may have also noticed that in winter times, when you stay inside the room of your house, you feel cold, and when you go outside, you feel warm and pleasant. But in the summer time, in the same room, you feel very hot. Why does this happen? What is this phenomena called? We will study about all this in this chapter. Now, the first topic, hot or cold. In our day-to-day life, you might have noticed many objects. Some are hot, some are hotter, and some are even cold. How do you differentiate these objects? By the sense of touch. You touch them and realize that this object is hot, this object is cold. You touch ice cream, you say this is cold. You touch a cup of tea, you say this is a hot. But is our sense of touch really a measurement for the hotness of an object? And is it even reliable? We will learn about this through this activity. Okay students, now we will do activity 4.1. For this activity, we need 3 beakers. Beaker naming A will contain cold water. Beaker B will contain hot water. And in beaker C, we have mixed A and B and it is normal temperature water. Now, for this activity, first I will put my hand in beaker A containing cold water. Then afterwards, I will take my left hand and put 2 fingers in hot water. I will keep them like this for 2 to 3 minutes. It's been 5 minutes already. Now I will take out my hands. My right hand was in cold water. When I put my right hand into normal water, I feel warm, typically warm. Now, my left hand, which was in hot water, when I put my left hand into normal water, I feel cold, a lot cold. This activity suggests that my sense of touch is not a reliable measure of temperature. I cannot tell what is what. So friends, you can do this experiment with adult supervision. In your home also, you can get a better understanding of our unreliability of sense of touch. So apparently, the sense of touch is not very reliable in terms of temperature. What is temperature, you ask? We can define temperature as a reliable measure of the hotness of an object. Students, have you ever noticed a thermometer? We use a thermometer to measure the temperature of our own bodies. The thermometer which we use to take temperature when we get cold or when we get fever, you might have noticed that in your homes too. That thermometer which is used by us in conditions of fever and etc. is known as a clinical thermometer. It ranges from 37 degrees Celsius to 42 degrees Celsius. Refer to the figure. A clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end. This bulb contains mercury. Outside the bulb, a small shining thread of mercury can be seen. You will also find a scale on the thermometer. The scale we use in the thermometer is known as the Celsius scales. It is denoted by the symbol of degree, capital C. To demonstrate more, we will do this following activity. Now, let us learn how to read a thermometer. First, note the temperature difference indicated between the 2 bigger marks. Also note down the number of divisions between these marks. Suppose the bigger marks read 1 degree and there are 5 divisions between them. Then one small division can be read 1 by 5, that is equals to 0.2 degrees Celsius. Wash the thermometer, preferably with an antiseptic solution. Hold it firmly. Give it a few jerks and then monitor the thermometer. Closely determine how is it. Now place the bulb of the thermometer under your tongue. After 1 minute, take the thermometer out and note the reading. This is the temperature of your body. The temperature should always be stated with its unit degree Celsius. What did you record as your body temperature? Note it down. The normal temperature of human body is 37 degrees Celsius. Actually, what we call the normal temperature is the average temperature of the general healthy public, which relates or comes near down to 37 degrees Celsius. Now, a human body temperature cannot go below 35 degrees Celsius or more than 42 degrees Celsius. Hence, a clinical thermometer has the lower rating of 35 degree and higher rating of 42 degrees Celsius. Caution students, do not use a clinical thermometer for measuring the temperature of any other objects other than the human body. Now students, you have studied about the clinical thermometer. But what if we want to measure temperature of some other body? We cannot use a clinical thermometer for that purpose. Herein comes a laboratory thermometer. A laboratory thermometer is used to measure temperature of different things. Kindly refer to the figure. Look at it carefully. The highest temperature and the lowest temperature is very different from the clinical temperature in the laboratory temperature thermometer. The lowest range is minus 10 degrees Celsius. The highest range is 110 degrees Celsius. Now, to learn more about this thermometer, let us do the following activity. Now, let us perform another activity. In this activity, we will measure temperature of water in the beaker using a laboratory thermometer. For this, I have poured some water, tap water, into the beaker. Now, I will take a normal laboratory thermometer ranging from 10 to 110 degrees Celsius. Be careful while dipping the thermometer in the water. Try not to touch the bottom of the beaker nor the sides of the beaker with this thermometer. We will keep this in this position for about 2 to 3 minutes. We can see the mercury line rising. It's near about 24 degrees Celsius. This is the temperature of the water using a laboratory thermometer. Okay students, did you notice one thing, that as soon as you take out the thermometer from the water, the mercury levels start falling down, which means that it is not giving an accurate result. Now, why does this not happen in a clinical thermometer? To notice it once again, kindly refer to the figure. You can see that there is a kink in a clinical thermometer. This kink prevents the mercury from falling down and give you a more accurate results. Generally people, you might have noticed a frying pan on a flame. The frying pan is very hot, but still you are able to use that pan by using a plastic or a wooden handle. What is this phenomena? We will study about this now. Generally, the phenomena of heat transfer takes place from hot surface or hot area to cold surface or cold area. To understand about this phenomena more, we will do the following activity. Take a rod or a flat strip of metal, say of aluminium or iron. Fix a few small wax pieces on the rod. These pieces should be at nearly equal distances. Clamp the rod to a stand. Now, heat the other end of the rod and observe. What do you see? We will see that the pieces begin to fall. Which piece falls the first? Do you think that heat is transferred from the end to the nearest flame to the other end? Yes. The first end of the rod is hot and is transferring heat to the colder end of the rod. As a result, the point which is nearer to the flame gets affected very easily. This process of transferring of heat in metals is known as conduction. In solids, generally heat is transferred by the process of conduction. We can understand more about this conduction by doing this small following activity. So students, for this activity, I take a beaker, I pour some hot water into it, and now we will pour some things into it to see whether they will become hot or not. I will take a pencil, a paintbrush made of wood, a plastic scale, and a metal wire. I will leave them and we are ready to see the results of our small activity. First I will take out this scale. This part is slightly hot and this part is not at all hot. It's almost normal. Now I will take out this paintbrush. This wooden paintbrush is also not hot at all, slightly hot on the bottom end. I will take out this pencil, not hot at all, slightly hot in the bottom, but I can easily hold it. In hot water also it is not that much of hot. Now I will take out, this is very hot, metal strip. Now the results of our experiments are with us. Make a table in your notebook and note down the materials which are found hot and which are not. From this activity we can clearly see that metals are good conductor of heat, as whole of the strip was hot, whereas wood like pencil, this wooden brush and plastic scale is not a good conductor of heat. By this we can learn that the materials which allow the flow of heat from them easily are known as the conductors of heat, and the materials which does not allow the flow of heat through them easily are poor conductors of heat. We also call the poor conductors of heat as insulators, for example wood, plastic, whereas some examples of conductors are steel, metal rod, etc. etc. Now students, what about water and air? Have you ever considered that? Yes, water and air are poor conductors of heat too. But how does the transfer of heat takes place in them? We will learn about this by the following activity. Okay students, now for this activity we will be requiring a flask with water in it, a spirit lamp, a matchbox and crystals of potassium permanganate. Now we will take this flask with water in it. Now students, we have set up the apparatus. The water is almost warming. I took few crystals of potassium permanganate and put them in this flask. Now notice, this potassium permanganate should be dissolved in the water totally, but instead it is going upwards. Why is it going upwards? Because of convection. The water heated is going upwards and taking together the potassium permanganate, and the water in the side which is cool is taking the place of, and the water which is cold on the sidewards is coming in to take the place of the rising water. Hence the potassium permanganate is dissolving and going upwards with the water, whereas in normal condition the potassium permanganate should have dissolved totally and completely altogether. This is the process of convection in water. This water gets heated completely, which is in the flask. This way of heating is known as convection. Now, what about air? There is convection in air too. To explain the convection process in air, let us do the following activity. Okay friends, so for this activity we will be requiring a candle, matchbox and some very interesting insight into the logic of heat. Now, we have lit a candle. For this activity also, please take precaution. Do this activity with someone who is adult or under adult supervision. Candle is burning. If I put my hand on the side of the flame, I can put it here, I can put it here, much more nearer. My hand is not feeling any heat. I am very much comfortable here. But when I put my hand on top of the candle flame, at that much distance also I am feeling a lot of heat. If I put my hand slightly lower, it's burning. It's literally burning. I have to move my hand. Why was this happening? The air on the top of the flame is getting the heat, and because of the process of convection in the air, it is moving upwards. The rising air is very hot and the air on the sides is rushing in, which is cold. That is why when I put my hand on a lot of distance on top of the candle, I am feeling heat. When I put it on the side nearby to the candle, there is no heat at all. We can also see this activity by a simple strip. If I put this strip near the flame, there is no effect on the strip. But if I put this strip on the top of the flame, almost double the distance. This is burning. You can see the withering of this ribbon because of heat. We can clearly see the heat almost thrice the distance is acting on top of the flame because of the hot air rising upwards, and the sidewards air is cold. This process is known as convection in air. During daytime, the land gets hot very easily. As compared to the water, it doesn't get hot in that amount of time. As a result, the air above the lands get heated and started rising up. When it rises up, it leaves a void. To fill that void, air from the sea rushes in. This coming of air from the sea to the land is known as the sea breeze. And in the night, the process gets reversed. Kindly refer to the figure. At night, the water cools down more slowly than the land. So the cool air from the land moves towards the sea. This is known as land breeze. When we come out in the sun, we feel a lot of heat. But have you ever considered that how much of the heat is reaching from the sun to us? And by what process? Is it conduction or convection? As we know, for conduction and convection, a presence of medium is very necessary. But in space, there is no air or water. So how is that heat from the sun is reaching to us on the earth? This process of reaching of heat or transfer of heat without any medium required is known as radiation. For radiation, there may or may not be any medium. For example, when we sit in a room with a room heater, heat reaches to us via radiation. When we go outside and play, the heat from the sun reaches to us via radiation. When we take a hot utensil on the stove and take it out from the flame, the utensil is very hot and it radiates heat and cools down slowly. This cooling down takes place when the heat from the hot utensils is transferred to the cold environment. This is also an example of radiation. All bodies which are heated radiates heat. When radiated heat falls on an object, three phenomena happen: reflection of heat, absorption of heat and transmission of heat. The reflected heat goes away, the transmitted heat goes away, but the heat which is absorbed is the reason of the warmth of that object. This is also the reason for why you are advised to use an umbrella when you go out in the sun. Now students, you know that we wear light colored clothes in summer and dark colored clothes in winter. Why is it so? We will learn about this in this activity. We will take two identical tin cans, paint the outer surface of one black and of other white. Pour equal amounts of water in each and leave them in the midday for about an hour. Measure the temperature of water in both the cans. We will feel the difference that the can which is painted black has warmer water. So students, you might have get the answer that why do we wear light colored clothes in summer and dark colored clothes in winter? Because light colored clothes in summer absorb less heat, hence you feel pleasant, and in winter dark colored clothes absorb more heat, hence you feel pleasant. In the winter, why do we use woolen clothes? We use woolen clothes because wool is a poor conductor of heat, that is an insulator. So wool does not allow the heat to go out. Also there is air in between the strands of wool, which means that air also traps heat, and as we all know and we have learned in the previous chapters that air is also a poor conductor of heat. Now let me ask you a question. Suppose in winter weather you are given two options, either a thick blanket, single one, or two thin blankets with air in between. What will you choose to keep you more warm throughout the night? I am sure it's the second option. Okay students, now we will conclude these chapters for what we have learned here. Our sense of touch is not always a reliable measurement of temperature management. We have learned about clinical thermometers and laboratory thermometers. The range of clinical thermometers is from 35 to 42 degrees Celsius, and the range of laboratory thermometers is -10 to 110 degrees Celsius. The thermometers are used for measurement of human body temperature, and the laboratory thermometers can be used for the measurement of temperature of various other things. Normal human body temperature is 37 degrees Celsius. There are three modes of transfer of heat: conduction, convection and radiation. Dark colors absorb more heat, whereas light colors absorb less heat. Therefore, dark colors are more warm and light colors are less warm. Hence, dark colors are more preferred in winters and light colors are more preferred in summers. Also, the woolen cloth or fabric is a poor conductor of heat, and the thin layer of air inside the woolen fabric is also a poor conductor of heat. That is all for today, students. See you next time. Bye bye.